Okay, now let's talk about the last topic of today's lecture. It's the average value of a function. Okay, and the average value of a function is defined to be just a definite integral, but divided with b minus a. Let's see what I'm talking about. Suppose that you have a function which is continuous on a closed interval ab. The average value is defined to be this: f average, or AV. This is equal to 1 over b minus a, b and a are the two endpoints, times the integral from a to b f of x dx. Okay? So the average of a function is defined as so. Suppose that you had a constant function, f average. Okay? And here is the function f of x. This is the area underneath. Suppose that here was f average. It's not necessarily in the middle of a and b, but it's somewhere over there. So what you do is you create a constant function, always equal to f average. And then what you have is that the area of f average must be equal to the area of your function. So the idea is, suppose that my function was continuous, and suppose that my function was constant. What should that number be so that the two areas are equal to each other? So the area of f average, since it's constant from a to b, is nothing more than f average times b minus a, right? Because it's a rectangle, the length is b minus a, the height is f average. And the area of f of x, of course, it's that definite integral from a to b f of x dx. Now, in this case, we don't really care whether or not f is positive or negative, all right? So we are kind of abusing that definite integral to include negative functions as well. But if you see this equation, to get to the definition of f average, the only thing you need to do is divide by b minus a. So just f average equals 1 over b minus a integral of f of x dx from a to b.